Hello everyone and welcome back to MEM220 lecture number 9. Let's start today with something a bit professional about assembling, which is spring and screws. I will try to teach you how to create springs and how to create special screws with the bolts and nuts and how to assemble them in a professional way. So today the goals. One of them is how to create a helix, which is the radial library in the SolidWorks. And after that, I will teach you how to use a feature swept cut in order to have a thread on the cylinder of the screw. Plus, I'm gonna teach you how to design the inner thread of the nut, but in a different skills than this one. This is I will teach you using the helix and swept cut. We will create a thread, but here I will teach you a different technique, which is insert part, then using the feature combine. Plus, I will teach you how to create a thread using a ready library thread, which is available from SolidWorks 2016 and so on. Before 2016, it was not available in the SolidWorks. And as I promise you, every lecture we have some new add relations. So today I will teach you how to add a peers relation. So our training models will be this spring, plus bolt and nuts, and how to do assembling in professional way in order to let it rotate. Okay, this is actually my lecture number 9, but let's start to design these two models. So please open your SolidWorks and let's start together. Okay, I will open new file parts. Then I will start from a top plane in order to draw a circle. So the circle will be from the center. Before starting, don't forget to set it to MMGS. So let me start again. I will go random, then using smart dimension, I will give a diameter of 80 millimeter. Let me close my camera in order to let you focus on the SolidWorks. So after that, after you create this, directly go to feature, directly after sketching, directly to the feature, then curves. I will choose helix and spiral. Then you can see here the helix, it starts to appear. So here we have different definition set by SolidWorks, which is pitch and revolution, height and revolution, height and pitch. So you can choose whatever you want. For us, I mean, we are going to select this height and pitch, So I will set the height of my spring, which is 200 millimeter, and the pitch, which is the angle between the rotation. So as much as you decrease it, we will have a much number of helix turning, I mean. So if you increase the angle, it means the number of turning will be less. So I will set it to be 20, and then the start angle will be zero angle, clockwise. Then I will say OK. Okay. So now after that, I will try to use the swept bus. But if you remember, when I teach you swept bus, we need to have a profile plus the path. So the path is ready for us, but the profile will be a circle starting from here. Then it will cover all this path. So let me cancel it now. Then let's have a new plane starting from here. If you want right plane, you can use it. Or I will teach you how to create a new plane in order to start. So let me create from here a new plane. So I will choose this point and then feature reference geometry plane. Then something yellow will appear, yellow plane. It means still it's not correct. So the second reference will be, I can choose this path. Then I will have a new plane. You can see here the new plane. So the relation of the second reference, it will be perpendicular. So I will say okay. Then after that, I will choose this plane, sketch, control 8, and then I will draw a circle. But look, when I approach to the center, nothing will happen. So I will create a circle which is close to this original. So let's say here, for example, very random. I will give a diameter. So diameter of 15. I think even 15 is big. I will go for 10. It's random. Now just only for practicing. So after I finish, look, the center and this origin is not connected together. So I will try to connect these two. So I will push Control button on the keyboard, then select this, and then select this one. Then, sorry, some new. So I will just delete all of them. Let me start again. So I will select this, Control this one. Sorry, let me just go for the center. Okay. When I choose this center and this origin, nothing appear here as a relation. So actually it's not correct. It should be the center, this circle center, and I choose the path of helix, which is this one. Not the center here. It will be the path of this. So then a new relation will appear. So if you push pairs, look, it will try to put the center of the circle to the most closest point on this path. So the closest point in this path is here, but if you draw the circle somewhere here, maybe it will put it somewhere here. So pairs, it's try to approach it as much as possible. So here, because I draw it very close, so it will approach it to this point. Then I say okay. After that, I go to feature, swept bus, already the profile is selected, but the path, it will be this. You can see now. And then I say okay. You can see now. This is the spring. You can save it as part 14, for example. Okay. So let's start with a second training model, which is bolt and nut. I will go part. Then I will start to design the bolt from top plane. If you remember, previous week I teach you how to design a bolt without any thread. I will start with polygon with 6 faces, 6 edges. So I will go very random. Then the diameter will be 10. And then I go feature extruded bus. I will give a thicknesses of 3 millimeter, and then I say okay. Then to create this curve shape here on the edges, so I will select this sketch. All this step I already teach you previous week. I'm going a bit faster now. So from this center up to here, then I will go feature extruded cut. Then I will choose look, I will choose this flip side to cut in order to cut it from outside here. Then the angle will be 45 degree. After that I say okay. Then I will cut the bolt head from the outer edges, so the out edge of the circle. So after that I will go back side, which is here. I will select this one, sketch, then Ctrl 8. I will draw the circle. Then I will give a dimension of diameter of 5. Then directly featured extruded bus. I will give a length of 20 millimeter. And I say okay. Okay, so now you can see height of cylinder is 20. The diameter of this cylinder is 5. And this one diameter is 10 and height is 3. Okay. All those steps is already taught in last week. Then I will start with the thread now. In order to start with the thread, I will first draw a circle as I teach you for the spring. I will draw it from this face, so I will select this one, sketch, Ctrl 8. Then in order to draw the circle, if you want, you can draw a circle, or I can use this convert entities. Convert entities, directly I will have the circle. Then I go directly feature, curves, helix and spiral. Then let me just show you what's happened. Look now. Now I have the spiral, but look, it's go down. I don't want it to be down, so I will do flip reverse direction, which is this one. I will choose the height to be less than the total height, which is 15 millimeter. The total will be 20. The pitch will be 1 millimeter, and angle is 0, and this is clockwise. As I told you, as much as you increase the angle, which is pitch, the number of turn will be increased. I will say okay. then you can see here. So now I will choose right plane, not front. I will choose right plane because if you can look carefully, look, the starting point is this point here, from this point. So if I start from right plane, I can start from this point actually here, which is here. You can see this point. So look, is directly on the right plane. So front, it will be, no, it's far a bit, it will be here. So right plane, it will start from this point. So I will choose this right plane, sketch, then Control 8. And then I will now draw the profile which is suitable for one type of bolt, because actually the bolt has different type. So let me go to polygon, but now not 6 hexagon, it will be triangle, so 3. So I will start from this point and then I will go very random but straight up to here. You can see here, straight. Then I say okay. The height, it will be 1.27, 1.27, and now I will draw another line which is from here to here, vertical. Then I will remove all the extra stuff, which is this and this. Okay, then from this point up to here it will be 0.5. This is already now become 1. Okay, so it's true. Okay, 1.27 and 0.5. Now I say okay, then my profile is ready, my path is ready. Let's go for feature, swept cut. For swept cut, you need to have the profile, which is this, and I need to have the path, which is this one. Look, now I will have a preview. It's not so much maybe clear, but when I say okay, you will understand what's going on. Now we get a very nice professional bolt. You can see the shape of the bolt. Okay, so just one thing to be mentioned. Look, the end of this bolt is same shape of the profile, but actually this part is not desirable. If you go to any professional bolt, usually this is very smooth edge. So if you went to smoothing this part, so what I do, I choose this face, I go sketch, then I go convert entities. Look, I will have the same shape, then directly feature extruded cut. Look, I will cut this part, but look at this here, it will be cut in tangent way. So because of that I will have smoothing. If you say just okay, you will have the smoothing part of the bolt. From down part we don't need anything because it's already smooth. Okay, this part we already cut it. Okay, save it please, control save. Then let's go for the nut, how to design the nut. Now I teach you here how to create a bolt and to create a thread over this bolt. I will teach you now how to create a thread inside the nut, but in a different technique. So I will go new part. Then from top plane I go sketch, then polygon. I will choose 6, so hexagon. I will start from center up to here. The smart dimension I will have 10 millimeter. Then I will go feature extruded cut. I will also give a thicknesses of 3. Then OK. I'm going a bit faster now because this is already non-technique from previous week. I will choose this one and then sketch, then Control 8. You can choose the circle, draw up to the end, then feature extruded cut. I will go flip side to cut, then angle it will be 45. I say OK, and then I will have the nuts. Okay, so those steps is easy, I think. Now let's open a hole here in the center. So I will choose this face, sketch, Control 8. Then I will draw a random circle. I will give a diameter less than the diameter of the bolt cylinder. Bolt cylinder we gave already a diameter of 5. So I will give here a bit smaller, which is 3. Let's say 3. I will give 3. Okay. Then after that, you can choose whatever diameter, but less than 5. Please choose less than 5 because I choose in the bolt 5 millimeters. So I will choose less than extruded cut. I will cut through so through all. Then I say OK, and then I will have the knots almost ready. Just now few steps left in order to have the thread inside. You can add the thread using this feature, helix, blah blah blah. You can continue as I teach you before. But another technique in order to match between the thread of the bolt and this knot, I can go for different technique, which is insert part. Then I will choose the part which I design, which is the bolt. This one. Look, directly it will appear as a yellow shape, and one new window will be open here. Please be sure that this is selected locate part with move and copy feature. Otherwise, sometime it will not let you open the assembling window. Because of that, please select this one. Don't forget to select it. Okay, which is this one. Then put it wherever you want. So I will put it here. Then look, automatically it will open for me here on the left side the assembling window. Then after that, I will choose the inner cylinder of this, look, and outer cylinder of this. Then look, it's now mated together in the concentric relation. Then I will say OK. But still I didn't finish. Because why? Sometime even if you have this made, the inside thread it will not be so much accurate. So I prefer to have one more step. How we can do that? I can go from here. You can go here again, right click, edit feature. Look, the assembling window will be open to give another relation. So I will give this relation, this face with this face. Then look, the bolt will start exactly from the bottom of the nut. I want to have the thread from here. It's better because as you know, when the bolt start to enter to here, so it will start to enter from the bottom. So in order to be exactly sure that the thread is very accurate, so it's better to have this semi technique. Then I say okay. Just one thing I forgot as well. Oh no, I mean it's okay. This is okay. We can finish this way. Okay. So now I have two relation. I have first relation concentric and then another one coincident. These two faces. So this is concentric between this cylinder and this cylinder, and then coincident between this and these two faces. Then after that, what I will do now, actually we are not doing any assembling steps. I will just use this technique insert part in order to subtract this bolt from the nut. So how? I go to feature, combine. If you don't have it, go to insert features, combine. Also is available. Just click combine, then operation type, it will be subtract because I will subtract main body. This is our main body. Body to combine, it will be this, but the relation, it will be subtract. It will not add to each other. So if I say okay, look, I will have the thread ready inside. Can you see now? The thread is ready inside. Now our bolt and nut is ready. So let me save this as well. 13.2. And let's continue to the next step. Next step is assembling the bolt and nut together. So I will go new, assembly. So I will go to browse, select the two file using control button. You can select both of them. Then I will put one of them here and one of them I will put it here. Okay. So I will move this one. So I will go assembly, move component, rotate. So I will rotate it up, down, in this way. Then I say okay. Now let's add the relation. Let's add the relation. Okay, now let me start the mate. So I will select this cylinder. When I select this cylinder, look, it will select for me the narrow part of the thread. Control button and then choose this also narrow part here. The narrow part here. Okay, then after that I will go mate. The relation will be concentric. Then you say okay, but look, it will go up and down, up and down. Actually, I want to have it more professional way in order to rotate, to go up and down using rotation. So this you should go to this mechanical mate, which is screw. But if I did this now, nothing will happen. Why? Because I already say okay for this concentric. I will give the relation for this concentric. So I will show you from beginning. So this is not correct actually. So I will delete. delete, and I will show you from beginning. So I will choose this cylinder, the narrow part, or I will show you narrow part here. Control, then this narrow part, mates. Then before you say OK, you can go directly to the mechanical mate screw in order to say that these two mate, this relation is actually a relation of screw. So I can choose distance and revolution, and if you remember, we give a pitch as 1 millimeter, so I will give also here 1 millimeter. Then I will say OK, and look, now this cannot be moved without rotation. Look, I'm rotating the mouse, then look, it can go outside. You can say OK. It cannot go up and down without rotation. Impossible. Okay, you can just, you see, without rotation, I cannot go up down. So you can save this. Assembling file. Now, I will close this. I will show you the next technique of the creating the thread, but this is available in 2016 and later on. So I'll open the bolt part, which we designed this part. So I will show you, I will not design from beginning. In SolidWorks there is some feature. For example, here we have all the steps. So I will start from the steps after this. So look here, when I move to this line, I will have, look, a hand. I will just drag, and look, I can move wherever you want. Then I will move it up to here. Then look, I have no thread design. So I neglect all these steps. Then I can start my design from here again. What can I do? I just select this. I can go features, hole wizard, thread, this one. Can go thread. Then it's a thread location. I can choose face or edge. So I will choose this edge here. Then automatically it will create for me the thread. How much is the height? I can choose whatever I want. For example, for us, we choose before 15. So I can choose it 15. The type, we have metric die, we have inch, in inch or metric. And I have here many standard. It depends on the what type of screw do you want to design. Look, for example, if I choose this MEM220-1.5, I will have this shape. If I choose, for example, M12 1.75, all this is standard. It depends what do you want to design. You can choose the standard. Okay, so let me choose something now just to show you the design only. I say there is M5. Yes, M5 0.8. Yes, M5 0.8. This is metric die. It means I need cut thread, so it will cut inside. But if you need this metric tab, you should go for extruded thread, which is this one. So usually metric die is suitable with cuts. Metric die is suitable with the extruded thread. So I will go this way. Look, even the color is changed as well. So I will go here because I will try to cut this thread inside the cylinder. So then look, I will have this shape. You can see I cut it from here, and this is the profile with all the dimension. Look, this is 0.8 and it gives you all the dimension. So let me show you if I did, for example, different thing, which is metric tab with this extruded thread. You can see what will happen, the difference here. I designed the shape to be outside of cylinder, not cut it inside the cylinder. It will be just an extruded bus outside of the cylinder. So it depends on your design. What do you want to do? So for me, I'm gonna go for this way. Cut metric die, and then I say okay. Then in order to smooth this part, as I teach you before, I just only select this one, sketch, convert entities, then feature, extruded cut. So I say okay, so I smooth the downside. Then now let's go to upside, which is here. I will choose this one, sketch, convert entities, feature, extruded cut. Then I cut it in tangent way. Then you can see it's became smooth. It became smooth from up part and bottom part. I will save it. Let me just open the bolt as well if you want to see the change. So I can choose this one. Now it gives me one message, rebuild this document. I'm opening now the nuts. So why it give me this warning? Because I designed the nuts using this bolt. So if I say rebuild, it means it will use the new thread in order to have, I will just open my camera. If you remember, I mean, when I designed this thread, then I designed the nut. The nut, I open a small hole inside. Then I use this bolt inside and then I subtract. So because of that, when I open the nut again, it will tell me, do you want to rebuild or not? So if I say rebuild, look, it will automatically rebuild this inside part. Look, it subtract automatically this inside part. If you don't want to do this, just go again up to here before this add part. Then actually we need to have actually bigger. It should be here. So I should also modify this one to be different. It should be 15 millimeter. So actually is a bit difficult procedure. So you should make this is bigger. So first that diameter here, it's now 3, but I should make it 5. Then after that I should go to this feature, hole wizard, thread, and then you can add. So in order to be more accurate, I prefer you to have these steps, which is actually more safe and more easy to design. Okay, let me now open the assembly. Let's see what happened in the assembling part, which is assembly number 5. It will ask me again to rebuild, I think. Okay, it will ask to rebuild. Let's rebuild now. So I got here some error, which is this one. Let's check maybe only the error from the original part. I will just check what's happening going on. Okay, we open now this one. Look, the part is become too much messy. Why this one? Because look, after I design the thread, look, the SolidWorks return this line, but actually I don't want it. I want up to here actually for me. I don't want extra. So this is the new thread. Then this is the smoothing. Look, this is the smoothing. And this is also the another smoothing part, which is upper part here. Look. So every step it's registered here. So let me just up to here. Then I will save. Then I will go to the assembling part. Look, it has also another problem for rebuilding. It will give me some error because of the mate problem. We can also edit this one. So I can just go to this, right click, edit feature in order to edit the assembling, because here we have different technique of the assembling. The thread is ready by the SolidWorks. So I will delete those. Look, I will delete all of them. I will delete. Then I will just select again this here plus. If I select here now, look, if I select this inside inner part, look, nothing will be appear. So it's not possible. If I choose this one, also not possible. Look, you should choose here this part, which is this. Then you can see now we have the concentric relation. Then the mechanical made same screw with this distance and this one. So I say okay. Let me check if everything is fine. Look, now it can rotate correctly. It can go up and down. So save all, rebuild and save. But now I make the assembling on the new technique, which is this, without our designing helix, with the thread actually, the thread and this smoothing. So thank you guys for listening to our lecture number 9, and I hope you get benefit from this professional design, and see you next week with the last lecture of this course. See you and bye bye.